Okay, everybody. So let's start with, how about just number one? You can use our nice little chart tomorrow, on Friday. So this is the chart that I'm referring to. So if you have it, great. All right, everybody. So number one, if you're going to do that one, remember you sort of split them all up into their own sort of separate beings. Okay, everybody, when you have a negative under a cube root, you can just pull that negative out. So I just have a negative on the outside now. It's just going to come out and be out here. Okay, no big deal. Now I'm going to look on my chart under the perfect cubes and see if any of these divide into 192. And I want to find the biggest one that divides into 192. 64 3 times. Okay, great. So this is going to split up. I have that negative out in front, right? Cube root of 64 times the cube root of 3. The cube root of 64 is just 4. So I get -4 cube root of 3. Now let's handle the variables. If your exponent is smaller than the index, there's nothing to do. You can't simplify it. It's already as low as it's going to go. So that's literally just going to stay cube root of m squared. And same thing's happening with this one. That's just going to stay cube root of n. Now I multiply everybody that's not in a root together. Everybody that is in a root gets multiplied together, and they're in one big root at the end. Let me just refresh your memory real quick. If you had something like, let's say I was trying to do the 4th root of x to the 15th. So just as a separate example, I can't do 15 divided by 4. I can't do 14 divided by 4 or 13 divided by 4, but I can do 12 divided by 4. So I keep going down until I hit one that works. So that's going to split into the 4th root of x to the 12th and the 4th root of x to the 3rd. What is the 4th root of x to the 12th? X to the 3rd. And that's just going to stay 4th root of x to the 3rd. Okay, so anytime you have one of these ones with the exponent, if it doesn't divide evenly, you split it up and you keep going down until something does work. Okay, 2 problems like that. Now there's a problem like number 7. So that one, 4 minus 5 root 3. Okay, number 7. So first thing I have to do is distribute. So let's multiply this through. When you're multiplying the numbers that are not under the root together. So that's going to get me 20 root 15. And then when I multiply these two, the 2 not in the root, that's a -25. And then in the root, 15 times 3 is 45. You might be done, but you're probably not going to be. And I'm not in this case. How do I know? Because the square root of 45 can be simplified, can't it? That can be split up into the square root of 9 and the square root of 5. So that's really 3 root 5. So what I actually have is 20 root 15 minus 25 times 3 is going to get me 75 root 5. Now am I done? Yes, now I am. I can't simplify the square root of 15 any, because it doesn't have any perfect square factors. So that's as far as I can go. I can't actually do the subtraction because they're not like radicals. If they were, I could do it, but they're not. So I'm done. That's it. Okay. Writing the expression in radical form. So let's do 13. That one's a little bit trickier. So 13 has you 10x raised to the 5/6 power. So you have to rewrite that as a radical. What is the number that's going to go right there? Someone's saying it, I hear it. 6. The denominator swings around and becomes that bird on the perch, the index, right? And then whatever is I'm raising to that power goes inside, 10x. And then I'm going to raise the whole thing to the 5th power. That's it. So the denominator just becomes the root, and then we raise it to the power. So now in, let's try 15, where we're going the other way. So in 15, they give you the 4th root of 3x raised to the 3rd. So everybody take a moment and try and write that in exponential form. Go the other way. Okay, you wrote your answer? Do you need parentheses or not?
Yes.
Yes. If you didn't use parentheses, I'm sorry, but it's actually not the same thing. Why do I need them? Because all of 3x is being raised to this power, right? I need the 4th root of the whole thing raised to the 3rd. So this should look like this. 3x to the 3/4 power.
Wait, if there was a, on number 14, if there was a number before the end, could that have to be in parentheses then?
No, good question. So the question is, let's make one up. So if I had 3n to the 5/4, and you had to convert that into radical form, you got to ask yourself the question, is the 3 being raised to any exponent?
Oh, all right.
The 3 is not, it's only the n that's being raised to the 5/4. So this would look like 3 times the 4th root of n to the 5th. So you could, again, put the exponent right there, or you could have the exponent on the outside. But the 3 has nothing to do with it. The 3 is not being raised to that power, so it shouldn't be raised to a root either. All right. So there's the first page. Now on the inside, let's do something like 19 looks good. 81x squared, and then I'm going to raise that to the 3/2 power. Okay, what am I doing with this? Why, yes, everybody gets raised to the 3/2 power. This is all multiplication. So this is when I am allowed to give everybody that exponent. So that's now 81 to the 3/2. X to the what? X to the what? Three. Yes. You're multiplying the exponents. 2 times 3/2 is just 3. You're not done though, because you can actually do 81 to the 3/2 power. Think about what that's saying. The denominator says, hey, take the square root of this. Square root of 81 is just 9. And then cube that answer. So 9 cubed is 729. That's my final answer. Okay, we're good there. All right, 27, something like that. You've got 4√5 over 3√80. First thing, you're going to reduce the fraction 4/3. It doesn't reduce, but if it did, I would. Now, 5 and 80 are both under a square root. I can reduce them like a normal fraction. So I can reduce 5 over 80. That just becomes 1 over the 18. No, 16? 16. Right? 80 divided by 5, 16. Right? Am I right? You're making me second guess
No,
myself.
it was 16.
Okay.
Yeah.
All right, up top, the square root of 1 is just 1, so my numerator just stays 4. But downstairs, square root of 16 is just 4. 4 times 3, 12. And then let's just reduce that. I get 1/3. Done. That wasn't so bad. I can, but there's nothing like that on. Okay. And then moving on to the inverse one. So let's just do something like 37. Okay, inverse. So first of all, I'm going to write my equation as it is, just instead of writing f of x, I'm going to write y. Y equals x minus 2 to the third. So finding the inverse, there's only 2 steps. Step 1, literally swap the x and y. X equals y minus 2 to the third. There's step 1. Step 2 is now solve for y. How? What would my first step be to get that y by itself? I need to take the cube root of both sides because I need to undo cubing something. So let's take the cube root of each side. So now I'm here. I have the cube root of x equals y minus 2. And now I'm really close. All I got to do is add the 2. That's it. Be careful when you're writing this that you don't write the +2 underneath the cube root because it's not. They're separate. So there's 37. There's the inverse. Let's do, is everybody okay so far? I know I'm going fast, but I assume you're with me. All right, 41. We got to find the inverses of these two things. I'm going to write it as f of x. I hate n's. Sorry. Sorry if you like n's. And okay, h of x. X minus 5. All right, so I'm supposed to tell if these two are inverses of each other. So let's do f of h of x and see. Oh, that's the wrong way. So I'm going to take h and I'm going to put it into the f. So 2x minus 5 plus 5 over 2. And what do you know? Plus 5 minus 5 cancel out, and then you just have 2x over 2. Isn't that just x? Yes. All right, so that's good. So let's try it the other way. H of f of x. Let's take the f and put it into the h. So I want to do 2 times x plus 5 over 2 minus 5. Look what happens. The 2's are going to cancel. I have x plus 5 minus 5. Ha! It works. So yes, these would be inverses of each other. Yep.
So when you basically just look for if 2 numbers cancel out, that's like numbers. Like, could you just look at that?
Oh, you mean from the originals?
Yeah.
No, because it could be something so simple as like a sign is wrong. You know what I mean? So like even though the 5's cancel, maybe like if that had been a -2 instead of a positive, you really need to actually do it. Yeah, there's not. I mean, it's nice to see that things are gonna cancel, but yeah, there's no real shortcut. All right, 43. Let's try. Bless you. Okay. What's my step 1 for something like this?
Subtract.
I want to get the thing being raised to the exponent by itself. So let's minus that 9. Now what should I do? Yes, divide by 4. Now what do I do? I'm gonna raise both sides to that reciprocal power. Remember that? So I'm gonna raise this side to the 2/3. Whatever you do to one side, you gotta do the other. So I'm gonna raise you to the 2/3. So look what happens on the right. That just becomes n. How nice. On the left, you gotta simplify that. So what is 1,000 to the 2/3 power? What is it? Right, I'm gonna get 100 because I'm gonna take the cube root of 1,000, which is 10, and then square that answer. So I get 100. All right.
Can you do it?
A root? Oh, a negative? Sure. How about, what do you like, 45? Okay, let's do 45. A plus 2 to a negative 1/2 equals 1/6. Okay, so step 1 is actually already done. The thing being raised to the exponent is by itself. So that's good. Now we got to raise both sides to the reciprocal power. What's the reciprocal of negative 1/2? What's the reciprocal of negative 1/2? Negative 2. Yep. So I'm going to raise both sides to the negative 2 power. So on the left, that just becomes a positive 1. So I just get a plus 2 on the left. That's it. Look at the right-hand side though. What is 1/6 to the negative 2 power? You know this in your brain.
No.
It's 36. How? Let's talk about it. What's a negative exponent say to do? Take the reciprocal. That's what a negative exponent says. The negative piece of the exponent says flip it over. Because remember, everything upstairs has to go down and everything down has to go up. So it's the same thing as just flipping it all over. So that's the same thing as 6 to the 2nd power, which is just 36. And then minus 2, I get a is just 34. Oh, those are good. And you know what? Oh, you know what's not on here? I thought it was right in this section, but it's not. If it was written as a root instead. So I'll just make one up. I'm so sorry. I don't know how I missed that. But I'm talking about a problem that might look something like this. Something like that. So it's already written as a radical instead of an exponent. So how might you handle this one? Right, I got to cube both sides. So that gets me 125 equals, and that just cancels. So that's just 33 minus 4x. And then we could solve from here, right? We just minus the 33 divided by negative 4, right? That's it. What is that? I don't know. 92 divided by negative 4, 23. And there it is. Okay, so if you're given something that's already in radical form, that's all you got to do. Okay, and then the only thing left to do is a graph. So which of these 4 graphs do you want me to do?
50.
I figured. Okay, so if you were going to do something like 58. First of all, it's a cube root. Let's start with the parent function. 8, 2, 8, negative 2. There's the original, the parent function. If it helps you to make that little chart. 0, 0, 1, 1, 8, 2, negative 1, negative 1, negative 8, negative 1, negative 2. Just kidding. There we go. So that's the parent function. That's just the cube root of x. That's what it looks like. What does this 3 out here tell me to do? All my y values are going to get times by 3. So maybe I'll even make another column, times by 3. So it'd be 0, 3, 6, -3, -6. Right? So now I'm going to plot 0, 0. Let me switch colors. 1, 3. 8, 6. Bless you. Bless you. Oh my gosh. There's all my y values times by 3, right? So I get this green graph. And now I do have to do this last step. What does a +6 under the root tell me to do? To the left 6. So every green dot that I just made, I should shift it to the left 6 spaces. Eight, so now I'll do 2. Right, obviously I won't be able to put them all on here because I'm going to run out of room. So that is roughly my final graph. I would encourage you to plug in a point, at least one. So if I plug in -6, it should come out with a 0. It does. If I plug in -5, it should come out with a +3. It does. Oh my gosh. I love when it works. So I know I did it right. Guys, that's everything. I don't think this one will be too bad. Does anybody have a question right now before I cut this video off? Everybody's all right? You feel okay? All right. So let me shut this off. Bless you.